Before we move on to other types of exponential and then log equations, I want to just take a look at an application. Because we said that in the financial world, interest was a major application of exponential functions, and we can now use our skills to solve some of those application problems. So here, if I invest $10,000 at 2.5% annual interest compounded quarterly. Quarterly just means 4 times a year. Okay. How long will it be before my investment is worth $20,000? And we're going to give our answer in terms of the natural log, and we're also going to round to 2 decimal places. Okay. Now, just a reminder, as you're doing the homework, of course, you can flip back in your book to see what the relevant equations are. On exams and quizzes, I will not give you the formulas for interest. I do expect you to know those because we spent some time trying to derive them. So, let's remember, A is P times 1 plus R over N to the NT is my formula for compound interest if it's compounded N times a year. A was the value of the investment, and that would be a function of T. So at time T, T was our time, and that's given in years. P was the principal. That's just a fancy word for the amount that's invested. R is our annual interest rate as a decimal. So I'm not going to enter 2.5. That's as a percent. I'm going to convert that to the corresponding decimal. And N is just the number of times compounded per year. Now, if you're doing a problem like this on a quiz or an exam, I would strongly encourage you to write out the equation and then plug in the numbers. You do not necessarily need to write down what everything stands for, although you can if you find it helpful. Okay. What I'm going to do is just write down what numbers we're going to be plugging in for these things. I'm going to just slide this equation over here so I've got a little bit more space. Okay, so the value of the investment, well, we're wanting to know when the value will be $20,000. So that's what I'll be plugging in for A. T, that's the thing I'm going to be solving for, because the question says, how long will it be? How much time is going to pass? The principal is the amount that we're investing, so that's $10,000. The annual interest rate was 2.5%. That's 0.025. Remember, when you convert a percent to a decimal, the decimal point when it was as a percent was here, we move 2 places to the left. So I'm going to have to fill in a place holding 0. And I said quarterly just meant that we were compounding things 4 times a year. Okay, so if I plug in those numbers, we're going to have 20,000 is equal to 10,000 times 1 plus 0.025 over 4 to the 4t. Now, this sort of problem is the one time this semester it's going to be acceptable for you to have a mixture of a fraction and a decimal like that. In general, I'm expecting you to simplify things. Pick one. Either have a fraction or a decimal. The reason I'm not going to be super picky about this is that realistically, all we're doing is setting things up so that we're going to plug into the calculator. Okay. And I think it's actually simplest to just leave it like this and enter it into the calculator as is, rather than simplifying it by hand first and then plugging into a calculator later. So, because realistically, we're solving to get the exact answer, which we will express in terms of the natural log, but in a real-world application, you wouldn't say, I must wait the natural log of 7 years. You would plug into a calculator and see approximately how many years that is. Okay, so that's the one time I would allow you to leave something like this. Okay, so I want to try to solve for t. Let me give myself some space here. Well, if I take a look, this is my exponential expression right here. Remember, the exponential expression is just the base, which is this complicated 1 plus r over n, to the exponent. So that 10,000 isn't part of my base, so the first thing I would do is divide both sides by 10,000. 20,000 divided by 10,000 is 2. So then we've got 2 is equal to 1 plus 0.025 over 4 to the 4t. Okay, so you'll notice we're basically asking how long it's going to take for our investment to double. Okay, so now I'm going to take the natural log of both sides. My direction specified natural log. If they didn't, I could take either the natural or the common log. Natural log of 2 is the natural log of 1 plus 0.025 over 4 to the 4t. That log now allows us to bring that exponent down and make it a coefficient. So the natural log of 2 is 4t times the natural log of 1 plus 0.025 over 4. Lovely thing, that's just a number. It's a messy number because it's the natural log of a messy number, but that's just one number. We're multiplying it by t. We're also multiplying t by 4. So to solve for t, I would divide both sides by both of these numbers, 4 and the natural log of 1 plus 0.025 over 4. And so when we do that, we get t is equal to the natural log of 2 divided by 4 natural log 1 plus 0.025 over 4. Okay, so that's my exact answer. But, you know, if you were a banker and somebody said, how long before I'll have $20,000 in the bank, and you gave them that number, they're going to look at you like you're crazy. Okay. So I want to enter this into my calculator. I am going to remember that there are understood parentheses around that bottom because that's a multiplication problem there. So I do need to be careful how I enter this in. I'm going to hit ln of 2, okay, divided by left parentheses 4 times the natural log left parentheses again. I'm going to need to enter in both of these sets of parentheses. So 1 plus 0.025 divided by 4, close parentheses, equals. Okay, and that's going to be approximately 27.812 blah blah blah. I was rounding to 2 places, so that would round to approximately 27.81, and of course that's years. We were solving for time in years. Okay. All right, so a little under 30 years before we would double our investment. Now, in this case, I told you how much we invested, and then I asked how long before we had twice that much. I actually could have just asked how long before we double our investment. So let's try another problem. If I invest some money, now I'm not telling you how much, at, let's just say 2% interest, annual interest, compounded continuously. How long will it be before I double my investment? In other words, before my investment is worth twice as much as what it started with. Well, here, we're compounding things continuously. So the value of the investment is the principal times e to the RT. It's actually a much simpler formula when you're compounding continuously. A, P, R, and T still mean exactly the same thing they did in the last question. Now what's interesting here is I didn't tell you what P was. So I gave you a value for R, we're solving for T, But I didn't give you either A or P, but I gave you the relationship between them. If we've doubled the investment, the value is going to be twice the principal. That's going to equal the principal times e to the 0.02 t. So I took that 2%, converted it to a decimal, and plugged that in for r. So I didn't plug in numbers for A and P, but notice what happens. When I isolate the exponential expression by solving for P, it's going to cancel out on both sides. So I'll just have 2 is equal to e to the 0.02t. So that happened in the last case. We had a principal of $10,000. When it was doubled, it was $20,000. When we divided over by the principal, we got 2 because we had doubled our investment. So you actually don't need to know how much the initial investment is. The amount of time it's going to take to double your investment doesn't depend on how much you invested. It depends on what the interest rate is and how often it's compounded. Okay, so now let's solve this. Definitely, since e is my base, I'm taking natural logs. So the natural log of 2 is the natural log of e to the 0.02t. And here, because that's exponential with base e and that's log with base e, that log completely undoes that exponentiation, and I just get the exponent. 0.02t equals the natural log of 2. Let's divide both sides by 0.02. And so t would equal natural log of 2 divided by 0.02. Okay. Now again, I'd kind of like to see how long is that. So I'm going to pull out a calculator. Natural log of 2 divided by 0.02 is, this is 34.657 blah, 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 which would be approximately 34.66. Okay. Again, on exams and quizzes when you don't have a calculator, you would simply stop here. On a take-home work, I might ask you to give me the rounded answer. I recommend doing what I did here, which is writing out a few more digits with just a dot, dot, dot to say, hey, it goes on and on and on. Show me what the next digit is. That's what justified my rounding up to the 0.66. That way, if you just make a careless mistake in the rounding, I can tell that it was a rounding error rather than a miscalculation, where if you have the wrong answer because you calculated things wrong, that's a different kind of error. Okay, so this just sort of shows your work for that rounding step, and I'd encourage you to do that.